Hello. Thanks for coming out today. My name is Edward Thompson. I'm a program manager at Microsoft. I work on Git and version control primarily. And I'm really excited to be here at GDC. I'm really fortunate. A lot of people were really, sort of jealous about the GDC trip because we've got a lot of people on the VSTS team, Visual Studio Team Services. That's the product that I actually work on. A lot of them came up through gaming backgrounds, right? So we've got people who worked on Xbox or Xbox games. We've got people who write games in their spare time, and of course we've got a ton of people who just play games, right? They're hardcore gamers at home. And then there's me, who doesn't do any of that. So it was kind of a trip to actually be invited, and so I had to kind of understand what's going on in the game world. And so I dove in and got my feet wet with Unity, and I came at it from a version control background, and I started thinking about how I would use Unity as somebody building version control systems. And so I wanted to talk a little bit about some of the things that I kind of came up with while I was working through Unity. So I think the first obvious question is, why should you use Git if you're using Unity? Because there are a lot of different options for team collaboration with Unity. They've got their own tools, but I think it still makes a lot of sense to use a proper version control system, right? And there are lies, there are damn lies, and then there are statistics. But these are statistics from Stack Overflow, and it shows how incredibly popular Git is. So it's a powerful version control system. It's very powerful, and it's incredibly commonly used throughout the industry. So if you're a shop that does more than just Unity, I think it makes a lot of sense to start thinking about Git. If you're a shop that wants to collaborate with outside teams, I think it makes a lot of sense to use Git, because Git is the de facto standard when it comes to source code management. So it's incredibly popular, and there are a number of tools already that support it. So you can grab whatever your favorite sort of version control system tools are. You can use like Gmaster or SourceTree. You can use Git Kraken or Tower. There's all sorts of tools just on the client side alone that you can use. And then in the server side, of course, you've got like GitHub, Visual Studio Team Services. You've got all these really cool ways to manage your source code. The problem is that Unity was built before the advent of Git, before the explosion of its popularity. And so there are a couple of things that you kind of need to be aware of if you're going to want to put your version control, put your games, your Unity games, into Git. The first thing that you really need to be aware of is that you totally need what's called a Git Ignore file. Now, Git Ignore is a bit of metadata for your Git repository. What it does is it tells Git the files that it shouldn't care about, that it should, well, ignore. The idea being that if you do a build, you don't want your build output to actually end up in version control, right? You want your source, you want your assets in version control, yes, but you want your builds to not be in version control. You want to produce those every time from source. So you want to make sure that that gets excluded. You also need to be aware that Unity has a cache directory that it dynamically recreates, and that also shouldn't be checked into version control. So this actually tripped me up right away when I started playing with Unity. I had excluded my binaries. I had excluded the temporary folder, because that's really obvious. I'm looking and there's a folder called temp, and I'm like, okay, no problem. But what I didn't catch was that there's this folder called library, and that's where some cache data gets stored. And this is actually the Unity webpage. This is their documentation. That's how I finally figured out what I was doing wrong. Let me zoom in on that. So the library folder should not be included in version control. That's right from their website. So what does this look like if we want to exclude these changes from Git? So we can create a Git Ignore file, and we can put the library folder, we can put the temp folder, or we can not worry about it, which is what I actually should have done in the first place. And we can actually go online and get a Git Ignore file that is customized for us, that I don't have to worry about. This has been kind of crowdsourced from the community, and it's all on GitHub, so it takes pull requests. And so you can go to github.com/github/gitignore, and you can download the pre-packaged Git Ignore files for whatever project you're building. So in this case, I'm building Unity. I can go grab the Unity Git Ignore, but they're there for C#, they're there for Java projects. They're there for whatever sort of application you're building. You can just grab the Git Ignore right from GitHub. You don't have to worry about getting it right yourself. And once I was able to go grab that, I was much happier. The even easier solution is to not even worry about getting it from GitHub, because almost all of the Git hosting providers, when you create a new repository, will give you this. Visual Studio will also, when you're creating a new repository, will give you the Git Ignore file that's appropriate for the kind of project that you're building. So in this case, I'm hosting my repository in Visual Studio Team Services. Again, GitHub has the same sort of option. Let's take a look at that. So here, this is Visual Studio Team Services, and right now I've got a game that I built already, but I want to create a new repository to hold my new Unity project. So what I'm going to do is I'm going to pop up here to the new repository dropdown. I'm going to give it a cool name, and it's an awesome game with an awesome name. And now I've got this dropdown, my Git Ignore dropdown. And you can see that there's a bunch of types of projects there already. I can just scroll through and select the type of project that I'm building. Again, this is a Unity project, so I'm just going to start typing Unity. And I'm going to select it from the dropdown. And when I hit create, it will start building my new Git repository, and it will put my Git Ignore file in it for me. So I've got this new repository. It's only got one thing, and that is my Git Ignore. If I open that file up, let's click on that, take a look at what's in it. Now you can see that this is actually the customized Git Ignore file for a Unity project. Up at the top is the library directory. That's what the documentation told us to exclude. That's the cache directory that shouldn't be in version control. Then there's also a temp folder, build output, and then some customized stuff even below that if I'm using Visual Studio to access to work on my Unity projects. So this is a really important thing. This is a critical first step when you are building a Git repository to hold Unity. There's one more, sorry, I'll take questions in a bit. There's one more sort of metadata file for Git when it comes to Unity, and that's Git attributes. It's another metadata file that controls how your Git repository is laid out. And you might be familiar with this. In fact, I hope you're familiar with this if you're using Git already, because one of the really important things it controls is line endings. Now, this is one of those problems when it comes to Git and cross-platform development. Unix historically uses uses a new line as a line separator. Windows uses a carriage return and a new line. And when you mix and match, you can have some problems, right? So Git tries to normalize all the line endings for your repository to Unix style. And there's a couple of ways that you can do this. You can either set it up to be a configuration option called core.autocrlf. I know that's a mouthful, but that's not the right way to do it. Because the problem there is that that's a per user setting. That's something that I set up as a user that if I'm collaborating with you, that you also have to set up. And if we don't have it set up the right way, if our configuration options are mismatched, then you'll see all sorts of crazy things. You'll see line endings change. You'll see that maybe when you run git clone and then you run git status, it'll say that things have changed, which nothing changed. I just cloned the repository. So I can run git status and it'll say things have changed. I run git diff and it won't show me any changes. We call those phantom changes. There's all sorts of problems that can arise if you if you try to use that old style of setting. Instead, the best practice for line in a configuration is to set it up in Git attributes. And it's just as simple as a one-liner, star text equals auto. I'll have links to all of this stuff after the presentation, so you don't have to remember it. So that's kind of the simplest Git attributes that you need for collaborating on any project. So that's any source code project where you have Windows users, or particularly if you have Windows users on a bunch of platforms. The other thing that you might want to do if you're using Unity is that you might want to take this a step further. There's more than just line ending configuration in this Git attributes file. It also controls how files get merged. So Unity has a bunch of data files that are complicated to merge by themselves. And thankfully, it includes a helper tool called Unity YAML merge. And the awesome thing about this is that you can hook it up in your Git attributes. And so instead of, if I change, say, my .asset file in one branch, and you change the same .asset file in another branch, Git doesn't know what the contents of that file are. Git just looks at it as lines of text. That's it. And Git won't do anything smart about this metadata file, this asset file. But Unity does know what that is. So Unity has been nice enough to package its own tool that can look at the changes that have been made on both branches and reconcile it themselves. So that's called semantic merging. There's semantic merge tools for source code like C# and F#, and those are great, but Unity provides a semantic merge tool for its own data formats. And so I would really encourage you to hook this up. It will make merge conflicts much, much easier to deal with. It will take care of most of these things for you. It won't corrupt data the way Git could, and it won't leave conflicts lying around when it doesn't need to. There's really one more critical piece of technology that Git can offer for Unity developers, and that's something called the Git Large File Storage System, or Git LFS. Now, Git, so we need to do just a little bit of version control theory, and I promise I won't try to bore you too much with this. Git is what's called a distributed version control system. That means that we say that you get an entire copy of the repository. And we aren't kidding when we say that, because when you run git clone, it's called git clone for a reason, you get a full copy of the remote repository. Everything that exists currently in the current branch, but also all of the history. So you get every file that's ever been checked into the repository when you run git clone. And for images, for video, for audio, that adds up really quickly. So the problem is that, let's say I commit a file, the very first thing I do is commit an image, okay? That's not so bad. Having one image in your Git repository isn't so bad. It's when I change that image and check in another version, and another version, and another version, that it starts to add up. Now I've got 4 copies of this file as it's existed throughout history. So each commit has a full copy of this image that I've checked in. If it's a 1 megabyte image, now suddenly these 4 revisions, 4 megabytes. And so you can see in a Unity sort of game, in a Unity repository, I'm going to have a lot of these large assets. And as they change versions, as I iterate on them, my repository is going to keep growing and growing and growing. So what Git LFS does is it finds a solution to this problem by actually sharding the Git repository. So instead of checking in each version of this image over and over again, Git LFS allows me to move the data into a separate space that's versioned just a little bit differently and managed just a little bit differently. The amazing thing about this is that instead of having these images, when I use Git LFS, I have what we call just a little pointer file. So in my history, in my Git repository, I just have this little LFS file. It's about 128 bytes. It's not a megabyte like the pings that it's replacing. It's 128 bytes, and it actually just describes to Git LFS, to your client when you run git clone, how it can actually get the image contents itself. We can actually take a look at what this file looks like. This is the complete file that Git LFS uses when you check in an image. So it's much, much lighter. And Git LFS will then, when you use it on your client, will then look at this, know how to contact GitHub or Visual Studio Team Services or wherever you're hosting your Git repository, and pull it down separately. So the lifecycle is managed a little bit differently. You only get the image files that you need as you need them. You don't have to get all of the history going back however long your game's been in development. So let's actually take a quick look. So I've got a Git repository right here that I can clone. It's hosted in Visual Studio Team Services. So I'm going to clone it down, and it's got some large files in it. Great. So what I'm doing now is I'm cloning my Git repository, and actually in the current branch that I'm checking out, I only have 10 1 megabyte PNGs. That's not really that big, but as you can see, I'm downloading a bunch of files. It's going really slowly. That's because although I've only got 10 1 megabyte PNGs in the current version, I've checked in a bunch of history. And so I'm gonna interrupt this. I'm gonna cancel this clone because it's just gonna take forever, right? We're still at 0%. I've got the same repository with the same history that I've checked in with Git LFS instead. So let's clone that instead. It's called large files -LFS. Right. Look at that. We were stuck on that receiving objects phase earlier, and now it just finished, right? We still got those 2,000 objects, but instead of getting the full history with the PNGs in it, we've got this Git LFS data, which is much, much lighter. So cloned very quickly. It took just a second to download the 10 that actually need to get checked out that I'm using currently. It took just a second to download those as well. It didn't print any status. It went that quickly. So let's actually take a look at inside. Right. So here I've got, so I've got 9 1 megabyte PNGs and a little one, a nice little one as well. And I can, but these are actually the files as they exist they're actually image files. Let's take a look. I can open up one. Let's open this one, the nice small one. Hey, it's the Git logo. So I was able to get just the data that I need to work on, that I need to build, without actually downloading all of the history that I probably don't care about. I certainly don't in this case. Now, there's another technology that some people might think is a good idea to use here that actually performs a similar goal, and that's called a shallow clone, where you only download the most recent version of the Git history. So you don't actually download history, you only download the most recent commit. And that sounds like the same thing that we're doing, but it's actually not. A shallow clone is sort of deficient in Git's mind, right? You can do a shallow clone, and you won't get any of the history, so Git doesn't know about any of the history. You run git log and you'll only see the most recent version. If I run git log here, I'll see all of my changes because I have all of my changes. I just don't have the binaries. Those are in Git LFS. The more important thing is that I have all of my branches. If I did a shallow clone, I would only get the most recent commit on the current branch. But here, I've got all of the branches from the remote server. Let's take a look. If I run git branch -a, you can see that, and git checkout old branch. And so now I'm actually able to switch to a different branch. And if I run ls, it's updated the files that have changed on that branch. Finally, I can just open up. Let's open up image 5 again. That's the one that changed. And before, it was the red logo, now it's all blue. So by using Git LFS, instead of doing a shallow clone, I'm able to still keep all of the information about my branches. I can switch to branches, and as I do, Git LFS downloads the data on demand, downloads the images on demand. Now, that does mean that I need to be actually online if I'm switching branches that update images, that update artwork or movies or audio, but that's actually kind of a nice trade-off in terms of not having to get the entire history when I clone. Okay. So if I close this, I can also run one command, and that's git LFS lock. So this is an important command when you are working with assets that aren't generally mergeable. If I have an image, if I have an audio file, and I want to make changes to it as an artist, then I want to be able to lock that file so that nobody else can make changes at the same time. Because if I save a wave, and somebody else saves the same wave, we're not going to be able to merge that. We're going to have a merge conflict. More importantly, we lost work because while I was editing that wave, somebody else was doing the same thing, and one of us has to give up our changes, or we have to figure out how to reconcile our changes. And so we've spent a lot of time working on things that are ultimately not mergeable. So I can run git LFS lock on a file. This is new in Git LFS 2.0. And it will tell me that the file is already locked, and so that I shouldn't actually be making changes to it. When I actually go and push these changes up to the server and open a pull request, then I can unlock the file, and so anybody else can make changes to that file after I'm done with it. So it's a simple way to coordinate. It's one of the features of Git that's been missing for a while, and it's new in Git LFS 2.0. It's great for artwork, for audio, stuff like that. So I'm going to stick around and take questions, but I know I threw a lot at you and a lot of configuration options especially. So this is all documented, aka.ms/git with Unity. So thanks so much for your time. I really appreciate it. I hope you enjoy the rest of your GDC.